Hello guys, so today I'm making another math video and you can see this is a map of China and it's all in Chinese, so ignore the name of the cities. So we're moving from this city to that city. So the first city is called Lhasa and we can just simply call it point L with a city L. And the second city is Tianjin, we just call it city T. And we can see the coordinate of city L is -6 and -2. -6, -2. Of city T is 5 and 1. So if we are taking a plane, we go straight from city L to T. So that's 11 to the right and 3 to up. So we can write the vector notation by this a narrow sign, an arrow sign to the right, and LT at the bottom. And we have a sign. I don't know what it's called, but this is not a parenthesis. So we put 11 on the x-axis and 3 on the y-axis. So just now we to write it. Again, it's the sign, not a parenthesis, and x plus 11 and 1 plus 3. Because you are moving 11 to the right and 3 to the up, so that's the positive 11 and the positive 3. There's a third way to write it. Oops. So here's a third way to write it. You use a parenthesis and you put x at the top and y at the bottom. But on PowerPoint, I just can't type it. So let's just not use it. Let's just not use it. So this is the easiest way to go from city L to city T. Just go straight by taking plane. But what if you are by train or by driving? So if you're taking by train or driving, you have to pass at least 3 other cities to get to city L. So here's the road. From L to X, and from X to Y, from Y to S, from S to T. That's our final destination. The first, let's take a look from the first city L to the city Xining X. So the coordinate of Lhasa is just city L is just -6 and -2, but of city X is -0.75 and y is 0.25. So that's positive 5.25 to the right, and positive 2.25 that's up, and we write the vector notation like this: Lx 5.25, 2.25, and the other way to write it is x plus 2.25. Oops, type is wrong. So it's x plus 5.25 and y plus 2.25. And now we go from city X to city Y. That's Yinchuan city point Y. So from -0.75 to 1.25, we go 2 to the right. That's +2. And from 0.25 to 0.75, that's 0.5 to the up. That's +0.5. So that's up. And we write the vector notation like this: x, y, 2, and 0.5. We can write the x plus 2 and the y plus 0.5. We can write at 1/2. Now we're going from this city, city Y to city S, Shijiazhuang city S. So from 1.25 to 4.5, we move 3.25 to the right. That's positive. And you can see the y doesn't change, so so you do not move y. And this is how you write the vector notation. ys 3.25, 0. Well, you can write x plus 3.25 and the y. Because you are not moving y, so just leave it as y. You don't plus or minus anything. Okay, and the last step. If you move in city S to city T, that's Tianjin, our destination. So it's 4.5 to 5. That's 0.5 to the right, positive. And 0.75 to 1 is 0.25 positive. So that's up. That's how to write it. ST 0.5 and 0.25. Or you can write it x plus 0.5 and y plus 0.25. So combine those. We get from city L to X, we have this. From X to Y, we have this. From Y to S, we have this. And from S to T, we have this, and this is our answer by train we're driving. So you are passing 4 cities. Actually 3 cities on your way to from L to T. And thank you for watching.
Hey, so in this video we're answering that where in the world problem, and so I picked the country Spain, and I chose Linares as our starting point and our destination as Barcelona. And of course you're doing all this by means of geometry. And sorry for a brief explanation of this problem. What we're doing is we're explaining how to get from one city in a country to the next using vectors. Alright, so let's get started. So here I have just a real simple map of Spain, and here's Linares, and that's Barcelona right there on the east coast facing the Mediterranean. And that's our plane. That's our plane. Yeah, we're just floating, waiting for instruction, waiting on how to, get to Barcelona. So without further ado, here we go. Let's map out our trip. So you see I've gotten a coordinate plane right here, and there's Linares, there's final destination Barcelona, and then there's Zaragoza, which is going to be our stop in between. Alright, and then I've also got letters that correspond to each city, A, B, C, and then so right here for Linares, the coordinates for that are -1, -3, because it's in the bottom left quadrant, so it's going to be negative, negative. And then for our stop, Zaragoza, it's going to be 3, 3. It's the coordinates. And then finally, the coordinates for Barcelona are 7, 3. Okay, so now we can go over how to write vector notation. So in order to do that, what you want to do is you want to start out counting the horizontal steps, if that makes sense. Kind of like, say, this would be one step from here to here, and there, like that. And then after that, you want to go, you want to count the vertical steps. So let's do that for the vector AB, also known as Linares to Zaragoza. So it's going to be, we're going to count horizontally first, 1, 2, 3, 4, and then vertically 1, 2, 3, 4, 5, 6. So it's going to be 4, 6. And then we'll go over how to actually write out vector notation later. And then, okay, for our final destination, Barcelona, it's going to be 1, 2, 3, 4 horizontally, and then 0 vertically because we're not going up at all. Alright, so and then in the next slide here, I've just gone over how to write it. This is basically how you write it. So Madrid to Zaragoza, also known as AB, is going to be, there's two ways to write out vector notation. You can do it this way with kind of like a greater than and less than sign around it, or you can do parentheses with the horizontal on top of the vertical. But I'd say this way. So we have the horizontal 4 and then the vertical 6 from A to B. And then for BC, Zaragoza to Barcelona, we have 4 horizontal, then 0, obviously vertical. Okay. Yeah. So last slide. Oh yeah, okay, so here we are, Barcelona, that's us. Just waiting to land. Alright, so I hope that was clear. I hope it helped. Thanks for watching.
Hi everyone, today we'll be talking about vectors using the map of Greece. We'll be using vectors as a route for our starting point to our final point. So our problem is, first we'll look up a map of a country, which is Greece, then superimpose an XY grid over the top of an image. 3. Find a city in the lower left-hand side of the grid, quadrant 3. As starting point, make sure the city lies exactly on an intersection of lines. And finally, number 4, explain using vectors how you would go from the starting destination to the final destination. The endpoint of each vector should try to land on a city, or as close as possible, along the way to your final destination. It should have at least 4 vectors before you reach your final destination. For our procedure, we will use vectors into finding a way to get to our destination, which is from Argostoli in the 3rd quadrant to Athens in the 4th quadrant. For review, the upper right-hand corner is the 1st quadrant, the left upper corner is the 2nd quadrant, the left lower side is the 3rd quadrant, and the lower right corner is the 4th quadrant. So, our steps into solving the problem. Our first step is to determine our givens. So the first given is our starting point, which is Argostoli in the 3rd quadrant. Our ending point is Athens in the 4th quadrant. Each vector must end on a city and must have at least 4 vectors before reaching the final destination. Our second step is to set the relationship between givens and the problem. Because the problem is dealing with vectors, let's review what a vector is. A vector is similar to an array. They both look the same, but is measured by magnitude, length of a vector, and direction, way of a vector. The starting point of a vector is called the initial point, being indicated by a point or a dot, and the ending point is called the terminal point, being indicated by an arrow head. There are 3 ways to notate a vector: by the given notation, which is vector AB, or by counting the spaces between the 2 points. For example, point A is -4, -2, and point B is 4 and 2. Spaces between them is 6 up and 6 to the right. To notate them, we would add chevron 6, 6, or simply add parentheses and put both numbers on the top and on the bottom. Our third step is solving the problem. So our first vector would be to Argostoli to Arta. Our second vector would be Arta to Lamia. Our third vector is Lamia to Sparta. And our fourth vector is Sparta to Athens. Vector 1 has its point A is -3, -1. Point B is -2, 3. Our vector 2 is -2, -3, and 2 and 2. Vector 3 is point C, 2 and 2. Point D is 2 and -4. Vector 4 is point D, 2 and -4. And point E, 5 and -1. These are the points that make up the vectors. So, the definition of the spaces of the vectors mean how much space does from one point have to go to another point, such as the first vector. You have to go 1 space to the right and go 4 spaces up to reach the other point. So, the second vector goes 4 to the right and 1 down. The third vector goes 0 to the right or left and 6 down. And the fourth vector goes to 3 spaces to the right and 3 spaces up. So, to determine the total amount of all the vectors, we can create new vectors by adding the current ones, such as AC equals AB plus BC, giving us AC equals 5, 3. AD equals AC plus CD, giving us AD equals 5, -3. And finally, CE equals 3, 9. By adding the total of the new vectors, we can determine the total amount of all the vectors. So by adding all the vectors that we found, we got 13, 9. In conclusion to the video, the total amount of all vectors from starting point to the final point is 13, 9. Thank you for watching.
Hello, I'm Ian.
I'm Renee. I'm Steven.
Alright, today is going to be a very special type of practice. We're going to be reviewing some of the topics we learned this year in geometry.
And I'll be explaining later the connection between soccer and geometry.
I'll be explaining the vectors.
And I'll be explaining transformations.
Here is a layout of a soccer field. We can see many different shapes and sizes of geometric figures. First, let's start with some basic shapes. Each side of the soccer pitch, there are 3 rectangles. The outline of the pitch, the 18-yard box, and the 6-yard box. In the middle of the pitch, there is a full circle. It is divided by the halfway line, which acts as a diameter. Also, on the corner flags, there is a quarter circle which represents a 90-degree angle.
For the shooter, to place the ball where the goalie cannot block it, or to make a goal, he needs to shoot it to the left. This requires much direction and much power. You must hit a certain part of the ball to make the ball go left and into the net. The curve works then as a vector, giving us the magnitude from where the ball was kicked to where the ball ended up in goal. If Ian, the shooter, was about 15 feet away from the goal, vector A would be 7.5 feet and vector B would be 7.5 feet as well. This means that the ball began to curve at the point where vector A and B meet.
Now, I will explain where to kick the soccer ball with your foot for different types of shots. Let's pretend the ball is two-dimensional. This makes the ball look like a perfect circle. With the secant on the bottom right of the ball, topspin and a curve towards the left will be applied. With a diameter from the bottom to the top of the circle, a direct, powerful shot will be applied. With the secant on the bottom left of the ball, a topspin and a curve to the right will be applied.
In the shooting drill, I'll explain the translation problem. First, Ian, the shooter, shoots the ball directly at the goalie, or where the goalie is placed at the origin. The goalie blocks it, and then Ian uses translation to decide where to shoot the ball so the goalie won't block it. If the goal was 8 feet wide, Ian has to shoot it -4 feet and 1 foot up, which means 4 feet to the left of the origin and 1 foot above.
I hope you learned a lot today in this video. Goodbye.
Just want to thank all my fans out there. Yeah. Thanks for watching Disney Channel.
Goodbye. Alright, 3, 2, 1.
I'm fucking And a bunch of kids made teams because we said, look, there's gonna be kids who are really into it.
Hey, Mr. Bronte, over here.
I thought you just. I didn't know that you knew that. I thought you just left like Yeah, that's what we're gonna do. Oh, that's why, Ernest. We needed more flash.
Dude, we got him.
So you add all the times, and the other graph you use the velocity and then the speed.
Tell me what the
0.71 seconds. What's our next one? 0.81. And then 0.87, yeah.